Welcome back, ladies and gentlemen. Today we're going to solve a few rational equations and we're going to account for excluded values. I suppose that means the first thing you need to know is what is an excluded value, which we've talked about before in class a little bit, but it is a value that is not allowed for a value of x, or a value of x that would make anything undefined in the equation or expression. Since we're dealing with rational equations and expressions, that would mean, in this case, a denominator of 0. So if you want to find excluded values, all you have to do is kind of look at the denominators only and just kind of decide what value of the variable would allow that denominator equal to 0. So, or you could write a baby equation off to the side and just say m plus 1 equals 0, therefore m must equal -1. So like for this expression, we get a -1 as an excluded value. Here we'd get a +1. Here we get a 0, and here's another spot where we'd have a -1. We're going to get started with a technique that we've used before, like way back in 7th, 8th grade, called cross-multiplying. But it's going to have a little bit of a twist in there now that we know how to solve quadratic equations. So take a look at this problem. It's got one fraction on one side, one fraction on the other. The first thing we want to do is just look at excluded values on the original equation. We want to look now and see if we can identify any excluded values. And you can see from this x minus 5 right here, we're going to get a value or an excluded value of 5. That 3 will remain a 3 no matter what x is. So that doesn't give us an excluded value, but the x minus 5 will get us an excluded value of 5. The next step is to go ahead and cross multiply, and remember to do that. I just always recommend throwing parentheses around any terms that are separated by addition or subtraction on either fraction. And then the idea here is we're going to multiply across the diagonal towards each other. Now the twist here with you being 9th graders now is that we are going to have to do a FOIL right there. We have a binomial times a binomial, so I do not ever want to see you tell me that product right here is x squared minus 15 or plus 15. We have to do first, outer, inner, last, which looks like that. And then, of course, combine like terms. And we're also going to set it equal to 0 because that turned up an x squared. So the way that we're going to begin solving any equation with an x squared in it is to get it set equal to 0. This one happens to be factorable. It factors into 6 and 2, negative on both. And then by applying the zero product property, we get x values of 6 and 2. And given that this was a rational equation, we want to check that against our excluded value, which is 5. If one of our answers had become a 5, we would just cross it off and just say that's not part of our solution set. I want to do one more example of a simpler cross products type problem before we start making one of these sides of the equation have multiple fractions or multiple terms on one side of it. As before, we want to try to identify our excluded values first. We can see here pretty easily this would be a -4 that would happen here. This one's not so obvious. You can't really pick that one out. And if you set up an equation that says 5x plus 26 equals 0, then you would subtract 26 and divide by 5, which gives you a fraction. But, you know, if we end up with an answer at the end that is -26 over 5, well, then we have to throw it out. To get started, as always, throw some parentheses up. And then we're going to multiply across the diagonals. Now this time we have an additional term here, but it's basically the same as the last problem. So I go ahead and multiply those binomials together using FOIL. Here I'm going to do a little distribution. If this 2 were negative, just be wary of that you'd have to distribute a negative along with that. It's not the case here, but just watch out for that. This is the result of FOIL on the left side. This is the result of distribution on the right hand side. We got some terms to combine, and then we can subtract 10x and subtract a 52, which gets us -3x and -40 equal to 0. And we want to try to factor that. This one's factorable again. We get x minus 8 and x plus 5, which gives us solutions of +8 and -5, and we just want to check those against our excluded values. They don't match, so that means both of our solutions are valid. This next problem, you should be able to identify it as being different than the other one. One, because there's no fraction on this side, but more significantly, that there are 2 fractions on one side of the equation versus just one on one side and one on the other. What we're going to do first is we're going to identify our excluded values. So here, if x were 0, that whole denominator would be 0. And here, if x were -1, the denominator would be 0. So let's just go put those in the box. Next up, we want to try to make this equation, we want to eliminate all of the fractions. So if we were to multiply by a 2x it would cancel out this one. But we can't just multiply one term times 2x because that would change the value of this term without changing or without a balanced approach. Remember, whatever you do, you have to do to one complete side of an equation. You have to do to the other side as well. And not only would I have to do it to this term, but I'd also have to do it to this term and, of course, the other side. So I could choose to multiply by 2x and it would cancel that, but it wouldn't do anything for this little guy. It would kind of create a mess over here, but a relatively small mess, so I might be able to deal with that. So the next thing we have to do is we have to deal with that, and that is an x plus 1. So if we were to multiply by an x plus 1, it would get rid of that one. It would kind of create a mess here, and it would kind of create a mess there, but that might just be something that we have to deal with. So that is indeed the technique. So we're actually going to multiply by both of them across all items. So we're going to take that combined denominator, and if you were to create a common denominator for all three terms here, that would be your common denominator. So common denominator, or just identify all of your denominators and you're going to multiply through with all of those. You'll notice the other thing I did here was I changed the subtraction between the fractions. I transferred that negative up top just so I don't forget it, because I'm feeling like there might be some distribution on my way here. So here's what happens. So we're going to take this term and we're going to multiply it by each of these terms in the equation. So as we multiply through, you notice that there's a 2x here that will cancel with a 2x there. Now those 2x's will cancel, but the x plus 1 for this term doesn't have anywhere to go. So it's just going to tack itself right onto the numerator, because you can view this as this outside term here as a numerator over 1. So it's going to tack itself onto this 3 here. If I go on to the next term, the x plus 1 is going to cancel, but the 2x is going to be left over, so it's going to tack itself onto the numerator there. And if I go on to the third term way over here, it doesn't even have a denominator, so everything is going to remain as is. So I get a bit of a mess on the right hand side where I just had a plain 2, but I think it'll be more manageable now that we get rid of all the fractions. The result of that line, if we look at that, remember the 2x went away on this term, so I just have the x plus 1. The x plus 1 went away on this term, so I just have the 2x. And on this one, neither term went away, so I have both of them. So now it's distribution, multiply these two terms together, multiply these three things together. So it's a negative 2 times a negative 2 times an x. That's like a negative 4x, and then being distributed onto each of those terms. So a little tricky, but we'll keep it going. The result of that line is this. We want to try to combine like terms as much as possible. You'll notice that there's a 4x squared and a negative, or sorry, they're both negative. Negative 4x squared, negative 4x squared. So if I were to try to get one over to one side or the other, or vice versa, they would cancel each other out. If I would add 4x squared and add 4x squared, they would cancel each other out. So that's good. And if I were to also subtract a 3x over to this side, that would combine to be a negative 7x, and then just divide by negative 7. Check that against my excluded values. They don't match, so I have a valid solution. Next one up's just a little messier. We got more terms, more fractions, but we're going to approach it the same way. We want to identify excluded values. So right here, if x were 3, that would cause a 0. If x were 0, that would cause a 0. And if x were 3, it would cause a 0. So we've got excluded values of 0 and 3. Next up, I just want to throw some parentheses around there just so I know what I've got. And I just want to pay attention to these denominators, because I'm going to choose to multiply through by the least common denominator. So I'm going to have an x minus 3 and an x, and that will cancel everything out because I already listed an x minus 3. So I'm going to choose to go multiply through with an x times an x minus 3. If I do that, on the first term, the x minus 3's cancel, but the x remains. Here, an x would cancel, but an x minus 3 would remain. Here, an x minus 3 would cancel, but an x would remain. The result of that line looks like this. So I have those three items. I could distribute that 1, sort of, and then I have to distribute that x from the right. No big deal. I'll end up with an x squared on the right-hand side, so I know I'm going to start thinking, oh, I have to solve a quadratic equation, which means I should probably set this thing equal to 0, so I'm going to try to swing all of these things over onto the right-hand side. The result of doing that is that, and then that is happily factorable into x minus 3 and x minus 4. Applying the zero product property gets me solutions of 3 and 4. And then of course I want to check those against my excluded values, but this time I've got a 3 and a 3 that match. So that means that my x equals 3 solution is no good, leaving me with only one good solution of x equals 4. The last example I have today is basically just the same level of difficulty, except for one additional step where sometimes they'll throw a problem with you where you should see either a trinomial or in this case a binomial that is factorable on one of the denominators. So in this case we want to be able to identify that situation. And our excluded values. So we can see that we should get a -3 out of this one, but maybe this one, maybe not so obvious. It is plus and minus 3, so if you can see that, it's good. If this were a little bit more complex, like a trinomial, that would be much more difficult to see. So just keep that in mind. So maybe the best thing to do would be to factor it. Here's me throwing in some parentheses, and here's me factoring. So perfect square binomial, so plus and minus the square root of each term individually, and then we are going to decide what to multiply by. So if we look at our denominator here, we have an x plus 3 and an x minus 3, so we're going to have to multiply by both of those. Happily, the x plus 3 is already listed, so we don't have to do anything more, and this doesn't have a denominator. So we're going to multiply by an x plus 3 and an x minus 3. Doing that will entirely eliminate this denominator, so I'll just have a 36 on one side. Here, I'll have a x plus 3's cancel, x minus 3 left over, and here there's no denominator, so everything's going to stay there. So the result of that looks like this. So I'm going to have some distribution here. Now I could FOIL this, but remember where we got this from was actually this binomial right there. So I know that if I FOIL this, I'm just going to end up right here. So I can just straight up replace that. So I'm going to distribute here, and then I'm going to replace this with an x squared minus 9. And then you'll notice I got a -1 sitting on the outside of this whole thing, so I have to transfer that negative inside the parentheses. Doing that results like that. And then combining like terms, I got an x squared involved, so I definitely want to set it equal to 0 again. Doing that gets that. That's factorable. Gets me solutions of 9 and -3. And of course, one of our -3's matches, so we only have one valid solution of 9. I will see you again next time.